In this module, we'll be talking about general service and cryogenic tank cars. General service, low pressure tank cars. The reporting marks or the license plate of the rail car are specific to that one and only car. You will see them stenciled on the left side if you're facing the side of the car, stenciled on each end, and you may see one stenciled on the top of the car as well. Tank cars may also have additional markings on the outside. The proper shipping name, special hazards, and or the UN ID number may all be found on the outside to help you, as a responder, identify what may be inside. Commodities shipped in general service tank cars are liquids or solids at ambient temperatures and pressures. Below is a list of common commodities found in general service tank cars. General service tank cars have a shell thickness typically of 7/16 of an inch to 9/16 of an inch on newer DOT 117 cars. Capacities can range from 6,000 gallons up to 33,500 gallons and have loaded weights up to 286,000 pounds. Construction is typically of carbon steel, stainless, or aluminum. They have pressures ranging from 0 to 100 psi. Remember, low pressure general service tank cars are not non-pressure cars. They have tank test pressures up to 100 psi with working pressures up to 165 psi. They carry both hazardous and non-hazardous commodities. This is the legacy DOT 111 tank car. This design has been around since the 1960s and carries hazardous as well as non-hazardous commodities. You will still commonly see ethanol transported in these rail cars. When trying to identify a low pressure from a high pressure car, remember low pressure cars have multiple appurtenances on top. In this car, you will see pressure relief valve on the left, combination housing with a liquid and vapor valve in the middle, and a manway on the right. You will also see that belly or that bottom outlet valve on these cars. This is the CPC 1232 build specification tank car. While it's still a DOT 111, these cars have gone through upgrades such as a half head shield on each end of the car, and have also combined the liquid valve, vapor valve, and pressure relief valve under a bigger, larger protective housing on top of the car, similar to a high pressure car. Remember, you still will see the belly, the bottom outlet valve on these cars. The next gen tank car is the DOT 117 tank car. These cars have multiple safety improvements on them, such as a full height, half-inch thick head shield on each end of the tank. The tank shell thickness has been increased to 9/16 of an inch from 7/16 of an inch on a DOT 111 car. Has thermal protection around that tank, and it's wrapped in an outer jacket. The top fittings are also enclosed within that larger protective housing, and there's an enhanced bottom outlet valve design with the spring that leaves the pin disengaged from the ball valve during transportation to alleviate any leaks during derailment. On this slide, it's just a shot of a DOT 117 tank car. You can see that larger protective housing on top may be confused with a high pressure car from a distance. Again, look at the type of commodity and the car specification. This is an example of the top of a DOT 111 tank car. While this is an older car, you'll still see plenty of these out in service. You see the manway, the combination housing, pressure relief valve, and also a top operated bottom outlet valve on this car. While most of these cars will be similar, you will see some slight variances. There are multiple types of valves and fittings on top of a DOT 111 tank car. Again, if it's a 1232 or 117 car, the liquid valve, vapor valve, pressure relief valve will all under be one large protective housing. If it's a DOT 111 car, some of these items may be outside of that combination housing. Some of these valves and fittings include manways, bottom outlet valves, top unloading valves, vacuum relief valves, safety relief valves, safety vents, heater coils, insulation, gauging, and or outage appliances. This slide has a few examples of some appliances, valves, or fittings you may see on top of a DOT 111 tank car. On the left, you'll see an example of a manway. On the right, you'll see auxiliary valves such as liquid valve and vapor valve located underneath that combination housing. In regard to the liquid line, remember when trying to identify the liquid valve from the vapor valve, the liquid valve will always be the larger of the two. A common scenario for a release from a liquid valve could include the open valve itself and or a loose plug. The ball valve may be loose. Mounting flange to the pressure plate could be loose or deteriorated. Some of these valves thread onto a threaded pipe nipple out of the pressure plate. The valve body itself may be loose. Put a pipe wrench on there. See if you can tighten it if it's leaking down those threads. They also mount to the pressure plate with a 4-bolt flange. Make sure those 4 nuts are tightened and there's no leakage past there. Also check for the packing material around the valve handle itself. If it's leaking from that packing material, you can remove the handle and tighten that gland nut or that packing nut slightly. See if the leak stops. If the leak stops, put the valve handle back on and you have successfully stopped that release. With the vapor valve, remember this vapor valve only extends into the vapor space at the top of the car. If you're trying to identify the vapor valve from the liquid valve, the vapor valve will always be the smaller of the two valves. A few common scenarios for release from the vapor valve include an open valve along with a loose or missing plug. The ball valve itself is loose. Similar to the liquid valve, depends how the valve mounts onto the pressure plate, either through a threaded nipple or through a 4-bolt flange. Make sure all those connections are tight. Use a pipe wrench. Make sure everything is tool tight. Car may also be overloaded by volume if it's leaking out of the vapor valve. Remember, that line does not go down into the liquid space, so if liquid's in the vapor space, it will find a way out. Inside the next generation car housing, such as a 117 or CPC 1232, you will see the vapor valve, liquid valve, pressure relief valve, and the vacuum relief valve all under a larger high pressure style protective housing. This is the DOT 120 tank car built by Tesoro. As you can see from this picture, it looks like it has 2 large protective housings on top, but note the presence of the belly or the bottom outlet valve. As you note, the 2 protective housings on top of the DOT 120 car, on the left you'll see that they put a manway underneath the one protective housing, and on the right you have the normal valve configuration under the other protective housing. When it comes to manways, remember there's 6 or 8 swing bolts that are tool tight. Never use an impact wrench while tightening down swing bolts. There's a gasket that seals between the manway lid and the nozzle itself on the rail cars. If you suspect a leak coming from the manway area, don't just tighten up the swing bolts. Make sure you open up that manway lid and inspect that gasket first. If the gasket is faulty, replace the gasket, close up the manway lid, and tighten those bolts in a star pattern. The bottom right, you'll see the Kelso clincher, which instead of the 6 or 8 swing bolts has one large clamp that goes around. These are built into new construction on tank cars. While you may not see one, there are a few that are running out in the system. As I said in the previous slide in regard to manway gaskets, make sure you check that they're physically there, see if there's any damage or cracks. When you replace them, make sure never put gasket on gasket. Most cars come from the factory with a gasket in the manway lid itself. If that gasket is bad, you need to place a nozzle gasket on the tank car nozzle itself. Remove the bad gasket out of the lid and seal up the car. Again, never gasket on gasket. Always remove the defective or damaged gasket when replacing. When it comes to pressure relief devices, a pressure relief valve is designed to open and close over and over and over. Pressure relief valves are typically set at 75% of the tank test pressure. So say on a DOT 111, 117, or even the 1232 rail car, those are 100 psi tank test pressure cars. So that valve is designed to open at 75% of that tank test pressure or 75 psi. These valves may engage due to the tank car being overfilled, some type of chemical reaction inside causing excess pressure, or even a mechanical issue such as a broken spring. They may release due to failed O-rings, a compromised spring, or an incorrect adjusted spring pressure on the valve itself. Identify the setting on the side of the tank car that the PRV is designed to open and apply a gauge when in doubt. There are two types of pressure relief valves on general service low pressure rail cars. On the left, you'll see the internal spring valve where the spring and a majority of the mechanics are located inside the car itself. And on the right, you'll see an external spring pressure relief valve. If you note, the mechanics in that spring are above and outside of the tank car itself. Corrosive cars are a common tank car that you will see an external spring mounted on. Another type of common pressure relief valve is the Kelso. Kelso valve, while it looks different and you don't see an actual spring on this, still operates, opens, and recloses as a normal pressure relief valve does. Also set at 75 psi on a 100 psi car. You'll commonly see these in newer tank cars such as a DOT 117. Vacuum relief valves are designed to do just as the name says, relieve vacuum on a rail car. On older cars, you will see them located in the manway lid itself, and in newer cars, you'll see them located inside the large protective housing. There's two types of vacuum relief valves, actuating and non-actuating. The actuating valves, or as the old timers call the foot valve, would actually push down as you place pressure on the upper cap. That would release pressure, or you would hear a hissing. The other type, the non-actuating, is fixed. It doesn't move when you push down on the top of it. The O-rings would fail, which is the common point of release on these. Also, the valve itself may be loose in the pressure plate. There's no way to actually cap these or stop these from leaking if they do fail. So just make sure if you do identify this as the point of release, that valve needs to be removed and replaced with a pipe plug, either 1.5 inch or 2.5 inch pipe plug. Remember to tape that plug and tool tighten it with a pipe wrench. This car will also require an OTMA to move. When it comes to bottom outlet valves on low pressure cars, you may see a couple different variations. On the left, you'll see a car that has no skid protection around that bottom outlet valve. It's just the nozzle bolted to the bottom of the car that could shear off in a derailment. On the right, you'll see that belly or that skid protection. The 4-inch ball valve is actually protected inside of that skid protection housing, while you have the nozzle bolted to the bottom of that with a 4-inch cap and a 2-inch plug. That nozzle is designed to shear off in a derailment, leaving the ball valve closed and intact. If you see a drip or a leak coming from around that cap or from that 2-inch plug in the cap, first thing you should do is make sure that the bottom outlet valve is closed. Most cars have some type of diagram or instructions on showing the handle in its closed and open position. Again, make sure it's in its closed position and pinned properly. You can put a 36-inch pipe wrench on that 4-inch cap. Put some turns on it if possible to stop that leak. Also, the 2-inch plug itself just may need a little snugging up. If you need to replace that 2-inch plug, if it's dangling or hanging, make sure that that plug is taped and again tool tightened with a 36-inch pipe wrench. There also is a gasket inside that 4-inch bottom outlet valve cap. You should have one of those in your NARA responder bag if you have one. Again, 36-inch pipe wrench is key to making sure these are both tight. This is a bottom outlet valve on a DOT 117 car. The difference with this is the way the handle actuates the ball valve itself. You can see in the photo, you see that pin and that spring. To engage this valve, you actually grab the left end of that handle and pull out on that handle. When you do that, that pin pushes in, actually engages inside the valve itself to allow it to open or close. In transportation, that pin is disengaged fully from that ball valve to prevent any releases during a derailment. If you have a leaking bottom outlet valve and do not see a handle underneath the car, then you're most likely dealing with a car that has a top-operated bottom outlet valve. These are located on the top of the car, usually on older DOT 111 cars. If you see that appurtenance on the left, looks kind of like a T-handle, there is a rod that goes all the way through the middle of that car from the top to the bottom outlet valve. Take that cap about 1/8 of a turn it upside down on that shaft, and hand tighten that valve. Do not put a tool on that valve or you could break or bend that rod. When we have a derailment and we have a release from a bottom outlet valve that can't be controlled, these bottom outlet valve magnets are available. You can place those on the valve to stop that leak. You may find them on any of our fire trailers throughout our system, as well as your local hazmat manager will have 1 or 2 in their vehicle as well. Some commodities are loaded hot into cars. They cool down in transportation and must be reheated once again at destination to offload. Some cars have internal heater coils, which are coils that are internal of the tank. They pump steam in one pipe. It runs through the belly of the tank, reheats that product, and gets it to a temperature and fluidity to offload. There's caps on these pipes underneath the car that must be in place at all times during transportation. The other type of heater coil are the external heater coils. As you can see in this photo, these are heater coils external to the tank itself. The insulation and jacket have been removed off of this car to show you how these coils run. On external heater coils, the pipes that hang below the car themselves do not require caps. You will see 2 pipes labeled inlet and outlet. The way these work is they pump steam into one of these pipes, they snake through the heater coils, and the steam comes out of the outlet pipe. You will always see stenciling on the side of the cars that tell you if they're interior or exterior heater pipes, and if caps are required on the inlets and outlets. Remember, if you're getting a call for one of these cars and you have a clear liquid leaking out of these pipes, it's most likely just condensation from the steam process. Use your pH paper to confirm that. Another type of low pressure general service rail car are the corrosive cars. While most of them do not have bottom outlet valves, some do. On top of a corrosive car, you'll see a couple styles of housings. On the left is the more modern configuration, where you'll see the fill hole, a liquid line, a vapor line, and the pressure relief vent. These cars don't have necessarily a pressure relief valve. They have a one-time vent that will rupture from typically a hydraulic surge. On the right, you'll see an older configuration with the mushroom type lid, and your rupture disc or pressure relief vent is located underneath that. On that older configuration, where the pressure relief vent is located under that mushroom type lid housing, when you open up that housing, you'll see a rupture disc, such as the picture on the left, that is in good condition. On the right, you will see a ruptured rupture disc. You should have these in your NAR bags. To replace one of these, you can just loosen up those 4 bolts, slide that top flange out of the way, remove the old disc, put in the new disc, replace the flange, and tighten up those 4 bolts. And once the car is cleaned by a contractor, you can send that car on its way. This is the vent housing on that newer style corrosive car. This is the Salco Tri-Vent. So in a similar fashion, this disc will rupture inside this housing. There's an inspection port on the top that you can unscrew, look down inside, and see if that rupture disc has failed. If it has failed, there's a second collar in there that you can unthread, remove the bad disc, put the new disc in, replace that collar, and then replace that inspection vent. Make sure you clean that car up before you send it on its way. Okay, now that we finished talking about general service low pressure tank cars, now you have to remember where the most common leaks will be on these cars. Most of you have seen leaking manways, so remember these could just be loose bolts or a bad gasket or a combination of both. Remember to inspect that gasket and make sure those bolts are tool tight. Look for leaks from bottom outlet valve. Could be an open valve, could be a bad gasket, could be a loose cap or loose plug inside of that cap. The frangible or rupture disc failure, you'll typically note dried product down the side of the car. These are usually caused by failures from humping these cars. Hydraulic surge will shoot up and rupture those discs. Make sure you get that car clean, replace that disc, and then you can send it on its way. Top operated bottom outlet valves, remember look for that extra appurtenance on top of the car, and any other auxiliary valves you may see on that car itself. In this section, now we're going to talk about the cryogenic tank cars. The cryogenic family, or the DOT-113 tank cars, are used to transport cryogenics and other extremely low temperature products. Usually easily identified by their absence of a protective housing on top, but not always. And you may see external vent lines as well. Here's just an example of one cryogenic tank car. Notice the absence of a protective housing on top, and you'll see that toolbox on the side. That's where all the valving and relief valves are located on this car. Here's just another example of a cryogenic car. While there is some type of a fitting housing on top, you'll see that toolbox or that valve box on the side. Again, if you're not sure, look at the placard, look at the UNID number, identify that commodity, and then that way you should know if it's a cryogenic material. A few common cryogenic commodities that we transport on BNSF are argon, carbon dioxide, liquid ethylene, and you may see some LNG or the liquefied natural gas used for locomotive fuel or testing out there. So what are cryogenics? Well, they're really cold commodities. Typically have temperatures of less than negative 130 degrees Fahrenheit that can cause everyday materials to act differently. This material leaks and gets in contact with metals, it may cause embrittlement. So a cryogenic tank car is like a big thermos bottle on wheels. So it has an inner tank surrounded by a layer of insulation and an outer jacket wrapped around that. There is a vacuum drawn between that tank and that outer jacket. It's designed to protect the contents from ambient temperatures for up to 30 days. These cars must reach your final destination within 21 days, or you may start to see some pressure increases. All fittings for the loading, offloading, pressure relief valves, venting are all located inside those valve cabinets or that valve box located on the sides of the car. If you open up the valve box on the side of a car, you'll see a lot of vapor lines, rupture discs, valving, gauges, things like that. Unless you are directed by experts from a shipper or manufacturer, you should not be turning any valves or opening or closing anything in this valve box without direction from these professionals. You may cause a bigger issue by doing so. So the two primary hazards with leaking cryogenics are asphyxiation, since they displace the oxygen in the area, and frostbite, since these are extremely cold commodities. Some of these cryogenic materials may also be flammable. Make sure you continuously monitor for oxygen levels in the area and LEL or lower explosive limit downwind if applicable to the product. Never enter a vapor cloud or allow the product to contact bare skin without the proper PPE. So remember, I previously said about the vacuum drawn between that outer jacket and the tank itself. The internal pressure on these cars will increase about 3 psi per day while in transit. There's a vacuum plate, usually either on the top or on the end of these cars that you'll see it's round. That vacuum plate is held on by the vacuum drawn between the tank and the outer jacket. If that plate is missing, then we lost a vacuum on that car, and you'll probably start to see a pressure and temperature increase of that commodity. Here in this slide, you'll see an example of where you may see a pressure plate on top of a car. Again, if that plate is missing, then you'll start seeing some temperature and pressure issues with that commodity. Here's another example of the location of a possible vacuum plate. Remember, if you're seeing those increases in pressure or temperature, check for the presence of that vacuum plate. In the event of a derailment or a sideswipe in the yard and you see or suspect jacket damage to a cryogenic car, it would be wise to contact your hazmat manager, get a hold of the shipper, and start addressing this car, as again, you may see a rapid increase in temperature and pressure of this commodity. Some cars, such as argon or carbon dioxide car, have regulating road valves that are designed to vent normal in transportation. What these valves do is just naturally open up to relieve any kind of excess pressure on these cars. This is stenciled on the side of these cars if it is normal. This is an example of a carbon dioxide car venting normally from the road regulating valves. This is another example of normal venting from a regulating valve. This is an example of not normal venting on a cryogenic car. You see the vapor cloud at the bottom of the car, as well as the ice on the vent pipe and the valve box itself. Make sure you never open up that valve box when it looks like this. Your leather gloved hands will not protect you from extreme frostbite. This is another example of where we want to get a hold of that shipper and professionals right away that can guide us in the response of these types of cars. Again, this is not normal venting coming from this car. Notice the excess vapor as well as the icing on the box itself. This is what the valve box on the side of an argon car looks like when the doors are opened up. Note the extensive piping, gauges, and valving system inside. All of the valves inside of these valve boxes are held closed with turnbuckles because everything loosens up going down the railroad and never tightens up. So make sure, again, we are not reaching in there and turning valves and grabbing gauges and pulling switches. We don't want to do any of that inside of these housings at all until we know what we're doing. Here's an example of a protective housing on top of a carbon dioxide car. Note that you will see two pipes that come out of the housing itself, both labeled regulating valve. On the other side of that housing, you will see two more pipes. One will be labeled frangible disc or rupture disc, and the other one is labeled relief valve or pressure relief valve. If you're seeing venting coming from one of the two regulating valves, this is completely normal operation for this car, is no cause for alarm. This is a common source of calls for these cars, say with fire department response. You have to make sure you explain to them that this is normal venting. Now, if the venting is coming from the frangible disc or the relief valve, that means we've got to the stage past where the regulating valves can make that car happy. And we've built up enough pressure to first pop the frangible disc, and then it makes it to the relief valve if the pressure is higher. That would be a not normal situation on one of these cars. Thank you for taking the time to view this presentation. If you have any questions, please feel free to reach out to your local hazmat manager or even myself, and we can get those answered for you. Have a great day.